Okay, hello everybody. Yeah, we started the last week with the following so-called magic square, where we identify more or less four main aims we have in economics, in economic policy, and maybe the most famous one, steady and appropriate economic growth. And we have talked about this last time, what we understand by economic growth. And there it is especially really important that we do not only think about an increase of GDP, because GDP is the market value of all goods and services within a year, within a period for the final consumption. And therefore, it is like revenue in business administration, just the product of prices times quantity. And then if we take especially times like this, where we more or less hopefully produce the same as in the last year, but prices are increasing by about 10%, then of course the product of prices times quantity would be 10% higher than before. And in this case, would we really talk about that we have a really prosper economy in our country? Of course not, because we have only prices coming up, we have only inflation, and we wouldn't talk about this because, and therefore we go, if we talk about economic growth, we talk about the so-called real GDP, and real GDP is just a measure where we try to cancel out this price effect. So in general, nominal GDP, price times quantity, and therefore this measure can increase by increasing X or increasing P, and we try to cancel this price effect. And this price effect we can cancel in different ways. The most easiest one, I talked about this, is just fixing prices in some specific year, maybe 5 years or 10 years ago, and we are multiplying all quantities in history and all actual quantities just with this price level. Then, of course, we have cancelled the price effect out of our measure, but then we have some problems because during time, of course, some goods are vanishing, new goods are coming up, and especially in our digitalized world, the innovation process has become much faster and faster. So just around 15, 20 years ago, there we really have calculated real GDP via this fixed price basis, and we moved the price basis every 5 years. But this innovation process in goods became much faster and faster, and therefore these 5 years are not enough anymore. And also there is just this statistical effect that if we move every 5 years the price basis, then of course we have to change our time series in history every 5 years. So economic growth changes every 5 years in history. What was the growth rate in 1996 differs if we calculate this growth rate with price basis of 2010, or if we calculate this growth rate with the time spaces into 2005. So we do not have any stable time series in history. And also not the innovation process became much faster and faster. Also, so to speak, the quality of the goods changes quite fast. Take, for example, the mobile phone. 5 or 10 years ago, what was the ability, what you can do with your mobile phone and what you can do today with your mobile phone. So this is, of course, not the same product anymore if you go back 5 or 10 years in history. And therefore, we calculate real GDP, so to speak, that we move more or less every year the time basis. We always calculate the real GDP, taking the quantities of today, multiplying this quantity with the price of, so to speak, yesterday. And therefore, this real GDP moves up every year, and therefore it is also called a so-called chain index, because real GDP, the index for real GDP today depends therefore on the index of yesterday, of t. So index of t plus 1 depends directly on the index, the period before, on the index of time t. But the nice statistical property is then that the growth rate doesn't change. Although we change the prices with which we measure, with which we multiply our quantity, growth rates are stable during time. So maybe this we write also down, growth rates with this definition of a chain index, growth rates are stable during time. Okay, and then, of course, last week we went to a direct example where we have a very easy economy with two products, and here we had the prices, and then we directly calculated these chain indices, and also we calculated here the nominal growth rate, the real growth rate, and in the last column the price effect. And there we also saw that since I have here an example with quite high growth rates, larger than 10%, then price effect plus real GDP doesn't add up anymore to the nominal growth rate. And the reason for this was here that if we calculate averages, then in growth processes we always have to calculate, if we want to be exact, we have to calculate average growth rates via the geometric mean and not the arithmetic mean. So maybe we write this also, maybe on the next slide down here. Remember, if, so this is a rule of thumb, if growth rates are larger than 10%, for the exact calculation of average growth rates we have to take the geometric mean and not the arithmetic mean. But I think you have also done this in your statistic courses when you calculated average interest rates or something like this. So geometric mean and not the arithmetic mean. Okay, and after this example, we want to go to some real time series. Just wait that you have until you have written down it. Okay. If we compare nominal and real growth for Germany during the last 20 years, then not very surprising, almost always nominal GDP growth rates were larger than real growth rates of GDP. So the usual situation is that we have a positive price effect. And what we see here in 2021, there this increase inflation, it really starts that nominal interest rates almost doubled the real growth rate, and this will be even more in 2022, this year. So more or less the forecasts for this year in real growth rates for Germany are around 1.5%. And if we have our two-digit inflation rates of around 10%, then we will end up in nominal GDP growth rates also in this year around 10%. Okay, and this, in the next slide, we have a direct look at the price effect, and there we see only in the year 2000 we had this one year where we had a negative price effect, and in all other years we had a positive price effect. So this is the relative change of GDP. Deflator. And here we will talk, I think, also today about this, that we have to keep in mind that this price effect doesn't coincide with the usual inflation rate. And this we have to keep in mind because this price effect is, so to speak, our whole price effect of our whole economy. And if we talk about inflation, if you read in the media, in the newspapers, that inflation is about 10% in Germany this year or this month, then this focuses only on private consumption. So if you have a look at inflation rates, then you will see that these inflation rates differ to the relative change of GDP deflator. And when we have talked about inflation and when we have talked also about labor markets, then we will also talk about the difference of these different price measures and what is the impact of these different price measures in an economy. So if we sum up, then nominal GDP represents changes in prices and quantity, the relative change of real GDP represents only changes in quantity, and therefore this is a measure when we talk about the economic performance of a country. And the relative change of GDP deflation, with this effect we can correct the nominal growth rates in order to obtain the real growth rates. And be careful if you look in older textbooks and they are calculating real GDP via the fixed price basis I talked about also this morning, then the GDP deflator itself represents the price effect. But if we take the chain index, then we have also to calculate the relative change of the GDP deflator. So maybe if you read this, that you don't come in trouble, keep in mind calculating real GDP via fixed price basis, then GDP deflator itself represents the price effect, calculating GDP with the chain index, then the relative change of GDP deflator represents the price effect. Okay, and then when we want to talk in general, in our magic square about steady and appropriate economic growth, then of course we have not only this price effect for which we have to correct. We are also not alone in our country, and therefore the population in our country can change, and if you think of the calculating GDP via the expenditure approach, then of course every people who consumes in our country contributes to GDP, and therefore if there are coming more and more people into our nice country, then of course our GDP is increasing. Would we then say that our society is better off? Maybe not, and therefore we also in general have to correct the real GDP with the population increase, and this is done that we divide real GDP just by the number of inhabitants in our country, and then we come to GDP per capita. And here we see for Germany the difference is not very large, so it's almost the same if you go here until 2014. And the reason for this is just that during this time the number of inhabitants of Germany more or less stayed the same. But I think I had already shown you this here, or where's my... No, I think about this was on the... And when we have looked at the other slides, let me just see. Then this was maybe here. No. Is it missing? Oh, here it is. Sorry. So here that, especially if we compare Germany with United States and France, then these countries have much larger growth rates in population, but this fact changed a little bit during the last 5, 6, 7 years, and especially if you look here at the difference in the year 2015. This was the year of the refugee crisis when many people came from Syria to Germany, and there you see that GDP, real GDP, almost increased twice as large compared to real GDP per capita. So real GDP per capita was almost twice as large. Oh, not real GDP. Was almost twice as large as real GDP growth. GDP per capita growth rates, and the reason was the refugee crisis because of the civil war in Syria. Okay. So, and then we want to move to the next aim, and this is price level stability. And yeah, quite important is that we talk about price level stability. Of course, we do not want to have all prices stay the same during time in an economy, because in general, of course, we want to have functioning markets, and there we of course need the price process in order to come to market equilibrium. So we have to talk about price level stability, and I already mentioned this. This is not measured via the whole price index, the GDP deflator, but this is calculated via the so-called consumer price index, CPI, or if we have a look at the European Central Bank, which has a direct aim, also a quantitative aim, what they understood or what they understand by price level stability. And if we go to the Eurozone, then we have the so-called harmonized consumer price index, Hcpi, but these two numbers here only differ in a very slight way, though they are almost calculated in the same way. So CPI and Hcpi are almost calculated in the same way. Well, and I already said that we have a specific aim here, that we have, so to speak, a definition what the European Central Bank understands by price level stability. The ECB Governing Council considers that price stability is best maintained by aiming for 2% inflation. What is inflation? Inflation is just the relative change of Hcpi. And here, over the medium term means roughly, 2 to 5 years. This is not directly defined what means medium term, but medium term is somehow maybe up to 5 years or 2 years, at least 2 years, so that we do not have to act directly if prices are going up in the ECB when inflation rates are higher than 2%, because the aim is that in the medium term we have, so to speak, on average 2% inflation. And this is, of course, measured by the harmonized consumer price index, and also the Governing Council's commitment to this 2% target is symmetric. So if we differ from these 2% aim, it doesn't matter if it differs down or upwards. And this is really just a change during time, because the first definition was we have the aim of 2%, but then it was specified until 2019. This was this new definition we have since 2019, and until 2019 the aim was 2%, but near and not higher than 2%. And now we changed to medium term 2% and symmetric, so we don't care about that if we differ from this 2% aim plus or minus. So, and now we can ask ourselves why we want price stability in an economy. Because if we have a look only at our market process, then we would say, well, we want to reach the market equilibrium. But which price is considered with our market equilibrium? This is a free process. But then we also have to talk about what what is the reason that we come into this market equilibrium. And the reason for this is that in general, our price, the price of our good, is a signal of scarcity of our good. And if we have there, if you keep in mind that we would, or if you think about a situation where prices are really always fluctuating in a very high level, and you should make your choice, which goods shall I buy, then you can think of that you cannot make really stable plans about what you are consuming, what you are investing. And therefore, for a single good, of course, you could have fluctuating prices, but in general, if you want to calculate what you want to do with your income during 1 year or 2 years, then that you have still this signal of scarcity, in general, prices should not fluctuate in a very high way. So if we go, for example, right now to Turkey, there you have inflation rates about 80% or 100%. And this is, of course, not very good for the economy, because then you have also unstable plans, especially for investment. And of course, you are earning your money today and you say, I worked very hard. So the first and maybe most important is that if you have really fluctuating prices, that prices do not, that they lose this signal of scarcity. But also if you look at your income, you earn this today, and then you think, well, I worked quite hard, but I do not want only to consume today, I also want to consume tomorrow. And maybe you want to save something. Then, of course, if you have on average a high increase in the price level, then of course your money is losing its value. And this is a huge problem right now. If we have 10-15% inflation rate and you still earn the same money, then of course you can buy next year much less goods. So this aim of price stability is a good aim in general for economy if you want to have more or less stable value of your money. And also, if prices are always differing, then you have, of course, transaction costs. Because you have always to say, well, again, my pizza costs tomorrow something else than today. So you have to write down your new menu card where you more or less write down that now your pizza is not costing 10 euros but 12 euros, and therefore this is called the so-called menu costs, because you have always to adapting your prices. And then I already talked about investing. Of course, if you take a credit today, you get the money today. And if you have high inflation rates, then you pay back your credit tomorrow. And so to speak, you obtain good money today, and you have not, if you have not this preservation of the value of money, then you more or less pay your credit back with bad money today, tomorrow, because the money, the value of your money has decreased during time. And this is then in general something like an injustice between these relationships between creditors and debtors. And of course, this is not very good for your investment plans. So this is a reason for unstable investment plans. And also, if you don't have stable prices, then you will also don't have stable plans in your decision. What should I consume today and what should I save today? And if you take that in general, if you remember the circular flow, in general we have investment equals saving. This also means unstable investment decisions. And this also influences, so unstable price level influences economic performance in a bad way. And also, if you go back in history, that then quite often an economic crisis, in an economic crisis, you quite often had unstable price level or very high inflation rates. And this is also a fear which we have today, that these high inflation rates, not only in Germany, but in whole of Europe, also in the United States, that from this you have these injustices in creditor-debtor relationship, and you have these unstable saving consumption decisions. So we cannot really make plans for tomorrow, and that this will end up in a huge economic crisis. So in general, via this consumer price index, we want to measure so to speak, the value of money, because the money has, via the prices, the purchasing power, and therefore we cannot look only at a single price. We have to look at many prices at the same time. So what we want to do is somehow calculating the average of many prices, and then we end up quite in the same way as we calculated GDP with the price index, and this price index is of course then calculated via a choice of a representative basket of single goods. So this CPI here, the basis of CPI and Hcpi is, so to speak, a representative consumer. What is an average consumer in a country consuming during 1 year, which kind of goods? So how do we do this? At first, we have to look what is this representative consumer consuming, which goods is he or she consuming. So we determine all relevant goods and services of this representative household. And then, of course, we have to weight these goods. Because, for example, a washing machine we do not buy every year, maybe every 5, 7, 6 years or so. But let's take a bread we buy almost every day. So we cannot calculate just price of a bread, price of a washing machine together. Washing machine, something like 500, 600 euros. A bread is maybe 3 or 4 euros. But we are buying a bread, maybe 100 breads per year. But we are buying a washing machine only every 5 years. So we have to weight these two prices due to our consumption. So this weighting is very important. And then, of course, we have a direct look. What is the price today of this good? And calculating this value of the basket is then just multiplying the determined prices with the chosen weight and summing up. So in the end, we have a weighted average of prices. And how we end up with our inflation rate. So again, as we have done it when we calculated growth rates of GDP, we choose just one specific year. We set to 100. This also moves more or less every 5 years. Right now, our price index of the year 2020 is set to 100. But of course, setting just one number to 100 doesn't affect the growth rate. And what we are interested in is the inflation rate, and the inflation rate is then just the rate of change of our price index. So what we can then say is inflation. Oh no, I think I have it here. There it is, yeah. Okay. So if you have a look at our European Statistics Office, then there the definition is the harmonized indices of consumer prices, HICPI is a measure the changes over time in the prices of consumer goods and services acquired by households. So this is our representative household. And they give a comparable measure of inflation as they are calculated according to our harmonized definitions. And we take this data every month, and here you have this definition as our weighted average. And these are the weights of the representative household. They do not have to coincide with your weights. And this you should also keep in mind. If you read in the newspaper 10% inflation, this inflation rate, of course, differs from your personal inflation rate. And it's quite nice if you click on this. There you more or less can calculate your own inflation. Oops, where is it? So this is on the German Statistical Office, and I think this has to be a bit smaller. That you see this. And here you just can put in, if you have your own consumption plan, you can put in your own numbers, what you on average pay for food when you go to restaurant, what you are paying for rent, if you have a car or something like this. And if you put all this together, then this calculator just calculates your own inflation rate. So let's just try. What do we have here? Let's say 100 for food, for alcohol, of course, nothing. Restaurants, 50. Housing, net rent, maybe 500. Gas, today, 100 for a single person. Electricity, maybe 50. Mobility, fuel, maybe 50. Public transport, let's also say 50. Recreation, how often we are in holidays, let's say 50. And lifestyle, I don't know, on average per month, 30. Your mobile phone, maybe 30. What else? Personal care. So, and I'm non-smoker. Let's calculate. Do we end up? Does it work? Oh, yeah. Oh, here. So I'm a bit less. I have 7.9% inflation rate. So you can try this by your own, and then you see what is your inflation rate compared to the official inflation rate. And here, this is, let's take this a bit larger, are the actual weights of Hcpi. And this is from the official definition from Eurostat. You can also have a look at this. So, and how do we calculate then if inflation rate? Of course, again, as we have calculated economic growth rates via GDP, is just the index today minus index yesterday divided by index yesterday. So index today minus index yesterday divided by the index yesterday. I think this is a good way to remember this. Okay, and as we have done this with GDP, we will do this also with a small exercise. I think you also can click inside here. Yes. So if you click inside, then you also open the Excel file. But this is, since this is quite unstable, I again go directly to Excel and oops, I put this and then let you see this up. Here, oh, inflation is there. Then so now you can see everything. So let's start. The definition is we have our prices and we have our weights. So we want to know what is the value of our basket in year 2017. What do we have to do in this case? Yep. €1 times the 0.3. Yes. 80 cents times the rate 0.7. Great. So let's do this again via our formula. So 1 times 0.3 plus 0.8 times 0.7. So we have 0.86. And again, as we have done this in the case of calculating nominal GDP, we just can move down this formula so we have all values of our baskets. So I put this inside here. This is then 0.86. 1.03 and 1.054, and that you remember this. Here we have 1 times 0.3 plus 0.8 times 0.7 equals 0.86. Then, of course, we want to have an index. And in order to obtain an index, we have to choose one basis here. Actually, we are free. We can choose 2017, 18, or 19. But I think the easiest way is to choose the 100 for the starting year. But you can do this also as an exercise, calculating the index for, let's say, 2019 as 100. This doesn't change, of course, the growth rates. So choose basis here for example 2017 should equal 100. So if we have now the value of our basket, that we know that 0.6 should be identified with 100, how do we calculate then the price index of 2018? So the question is, what do we have to write down inside here? Let's take another color. Take red. How do we come to this number? If we identify 0.86 is 100, then 1.03 is which number? Any idea in the internet? If we go back to our calculation of GDP growth rates, there we had more or less the same task. Here we had 419. This we have identified with 100. And then we ask the question, what do we have to identify with 520? And there we came to 106.1. So the way how we calculate this is exactly the same. Yep. So the relation between 103 and 0.86 has to be the same as the relation of our number we want to calculate and 100. This seems good. And how did you calculate this? What have you done? Hmm? Yes, definitely right. So in general, if we start a bit slower, then we would say that 1.03 divided by 0.86 equals our number we want to calculate divided by 100, and so we end up with x equals 1.03 divided by 0.86 times 100, and this is where we are here, 100. So we obtain 1.03 divided by 0.86 times 100, and you are definitely right. So it's roughly 119.77. So, and then of course, we come to this number here. Let's take green. That we have then 0.04 divided by 103 divided by 119.77, and this means x is roughly, again we can move down our formula here, 121.51. 121.51. So again, inflation in the year 2017. Can we calculate this? Index today minus index yesterday divided by index yesterday. Then of course we need the index of 2016. We do not have this number, and therefore of course we cannot calculate the inflation rate in this year. But then we are interested in the inflation rate of 2018. How do we calculate inflation? Yes? Hmm? Divided by price index yesterday, and which numbers we have to take? Okay. And then? Is this inflation? We also have to minus 100 in the price index today, and the nominator. Okay, so minus 100 here. And this will be, if we have here 2 times 100, then of course this is 19.77%, or because this is 19.77 divided by 100 is 19.77%. And the last one, let's take blue. Now let's do this also in Excel. So we have here equals minus 100 divided by 100. Inflation rate in 2019. Yep. This seems good. And how did you calculate this? Jawohl. Minus 100 divided by 100. Is this then the inflation rate of 2019? Yep. Yeah. Because then you would calculate the inflation of 2 years. Yeah. Yeah. So this would be the relative change in price level over the period of 2 years. But if we talk in general, or the definition of inflation is that we take only the difference with 1 year. Yeah. Okay. So here 119.77 divided 119.77, and this is then roughly 1.46%. And the last task, if you have already calculated, oh, I think I have to first close my Excel file. This I do in a minute. So we want also to calculate average inflation of these two inflation rates, 2018 and 2019. What do we have to do here? So we ask, starting from 2017, which inflation rate do we need, which is constant over the next 2 years, that we end up from 100 to 121.51. Yep. And the geometric mean of the inflation rates, or the geometric mean of what? So I want to have the exact calculation from you. The price index. So if we take just square root of 100 times 121. No. So again, if you take these calculation, I think you have seen this in your statistics and mathematics course. What do you want? What we want to do? We start with 100 times 1 plus our inflation rate, and this inflation rate now should stay the same over 2 years. So putting this number 1 time, then we are in 2018, and then we have to multiply this with the same inflation factor, 1 plus x, and then we should end up at the number 121.51. So this then means that we have 1 plus x equals 121.51 over 100 up to the power of 1/2, and that we see that this is a geometric mean, we can write this also as 121.51 divided by 119.77 times 119.77 divided by 100 up to the power of 1/2. I think I have to move this a little bit up. So, do we see this here? Okay, this we can still see. So the 1/2 is still seen. Yeah, okay. So, and here, these are the inflation factors of 2018 and 2019. And just taking the square root of the multiplication of two numbers is the geometric mean and not the arithmetic mean. So in general, arithmetic mean, this would be x1 plus x2 times 1/2, and the geometric mean is x1 times x2 up to the power of 1/2. So this is just more or less interchanging the signs. Plus sign with the multiplication sign and moving up the 1/2 from multiplying with 1/2 to the exponent of 1/2. Okay, but we have to also to calculate this number. So what we need here is the two inflation factors. Up. Up. Inflation factors, and this was for 2018 and 2019. One time we had this divided by this, and 121 divided by 119, and yeah, we see this. So let's take the geometric mean up. Of these two numbers, and we obtain 1.10, and in order to obtain only the inflation rate, we have to calculate then x, or let's say this here. So 121.51 divided by 100 up to the power of 1/2 minus 1, and this is then this minus 1. Oh. Here we need C11 and in percent. and 2 digits, 10.23%, 10.23%. And again, this differs slightly if we calculate this via the arithmetic mean, and the reason is, again, we have here an inflation rate larger than 10%. If you add up these, we come to 21.2 roughly, so the arithmetic mean would end up with an inflation rate of 10.6% or something like this. Okay, so maybe you go also through this calculation at home, because sometimes I ask something like this in an exam, and quite often I get all combinations of plus, minus, multiplication, and so on. And I don't think that it is too hard to calculate in a simple example inflation rates. And actually, quite often, if you're calculating revenues of your business or something else, it is always more or less the same, like this. Okay, so we end up for today. Thank you very much again. And then let's see on Thursday.